Up to the IPCC Assessment Report 4, scenarios were based on human behavior. This figure summarizes 4 of the scenarios. Here the y-axis represents an economic versus an environmental focus, and the x-axis a global versus a regional focus. To illustrate what this diagram really means, let's consider 2 countries, the United States versus Norway. Presently, the US is very focused inwards and on its own economy. So, in this framework, the US emissions would be predicted to follow an A2 pathway. Norway, on the other hand, would be more focused on the environment and have a greater concern for people worldwide. So they would follow a B1 pathway. Think about Canada. Where would it fall? On the left is what the different emission scenarios look like. On the right is how the carbon dioxide in the atmosphere changes in response to each emission scenario. Time is on the y-axis in both plots, is on the x-axis in both plots, beginning in 1990 and going to 2100. Notice the difference between emissions based on our predicted behavior of the US versus Norway. Notice the difference in the concentration of CO2 in the atmosphere by 2100. Over 900 for a US approach versus 460 parts per million for a Norwegian approach. The last IPCC assessment report, Assessment Report 5, used a different approach. They used representative concentration pathways, or RCPs. The name of the RCP indicates the radiative forcing at 2100 and represents a set of possible pathways. This table summarizes 4 scenarios. The first column on the left is the name of the pathway. The second column, the radiative forcing at 2100. The third gives a description of the type of scenario, and the fourth describes what the pathway looks like. The last column gives an estimate of the concentration of carbon dioxide in the atmosphere. Based on everything you know, and looking at the last column, what pathway do you think we should be on? 2.6, right? Do you remember what the concentration of carbon dioxide in the atmosphere is today? If you said 414 parts per million, you're correct. The last column indicates an RCP 2.6. We want to have carbon dioxide at 421 parts per million by 2100. This is becoming an increasingly difficult challenge. This is what the emission scenarios look like for the different RCPs. Again, time is on the x-axis, this time going from 2000 to 2100, with emissions on the left and concentration of carbon dioxide on the right. Notice that the concentration of carbon dioxide for RCP 8.5 at 2100 is about 900 parts per million, whereas the concentration of carbon dioxide for RCP 2.6 is just over 400 parts per million. Take another look at the emissions. Based on what we talked about at the beginning of this lecture, which pathway would you guess we're presently on? If you said RCP 8.5, you're probably right. This plot shows the many different pathways possible for each scenario. Look closely at the RCP 2.6 pathways. Notice that to stay on this pathway, not only do we have to drop our emissions to 0, we have to go below 0. What does this mean? It means that we have to do something to help take up carbon from the atmosphere. We'll talk more about this in Lecture 11 on geoengineering. The goal of RCPs, or other emission scenarios, is not to predict the future, but to help us better understand uncertainties in the future, make good choices, and prepare for potential outcomes.